Okay, shall we start again? Everybody downloaded the data and has Tableau, is able to run Tableau, hopefully. Before we jump in, this is only, I don't know, at the most an hour demonstration. I thought it would be useful to show everybody some more teaching, PGR skills teaching opportunities, right? So if you can find my amazing webpage and you add the letters DTC, Doctoral Training Center, on there, you can find lots more training activities at your disposal, right? Now this webpage is especially for the College of Science, but it's open to all postgraduate students across the university. Right, we have a special training seminar, and if you scroll down, you can see the program of events. Right, we already had an October event. What we do is we have these so-called community events. So we have lunch together for 1 hour, starting at 1 o'clock, and then we have a seminar followed by a seminar afterwards that adds to your portfolio of amazing skills. And it's open to the whole university. It's only advertised to the students in the College of Science, but it is open to everybody. So just for your future reference, if you're welcome to join us at any of those events. Now, if you missed some of those events, I tried to record them, and you can find them on the DataViz YouTube channel. So again, if you hit the playlists, there's one called College of Science Doctoral Training Center Seminar. Say that 10 times fast. And you can find lectures that have already happened, right? You can find like how to structure and write a scientific research paper, how to conduct a scientific literature survey, how to read a scientific research paper. That's a special skill too, extracting the essentials. Right, making the most of any meeting, like how to conduct a scientific meeting. Right, that's a skill too. Right, how to effectively communicate with your supervisor. Some of you might not have discovered how to do that yet. And just in other kinds of things. So look, there's visualization and practice, a live introduction and hands-on demo of Tableau. So what we're about to do. It's already recorded on there for everybody to see. And so if you get lost today, don't worry about that, because there's already a live hands-on video demo from Swansea University on YouTube for future reference. Yeah. Anybody have questions about that? And at the bottom there are links to other postgraduate skills training opportunities, right? The Swansea University training series and other related training events. So you could spend all your time training. Yes. Okay, good. So let's get our hands dirty. Computer scientists never get their hands dirty, actually. We just sit in the closet and hide from the world. So before we start Tableau, let's just familiarize ourselves with the data. So the data looks, before we look at the raw data, so to speak, we can have a preview of what it looks like in Excel. So what are we actually looking at? So we're looking at a huge data set, and it's a record of at least the recorded accidents, car accidents, all across the UK. You know, we don't know how many accidents there are that are not recorded. That would be fun. Maybe somebody in here could study something like that. But these are the recorded ones. So people get in their cars, they start driving, and they have an accident, right? And a lot of people die. Yeah, but nobody talks about it. So this is a description of lots of car accidents. Actually, so each car accident involves at least one vehicle. It could be more than one vehicle, but it has usually one vehicle. So there's the vehicle name. The vehicles are classified by their size, right? It could be a sports car, an SUV, wagon, minivan, pickup, and so on. The retail price of the car is actually given, the dealer costs. So if you want to know how much profit the dealer makes every time they sell one of these cars. The engine size, the number of cylinders in the engine, the horsepower, how inefficient the car is in a city, and how inefficient it is in the highway, how much it weighs, and so on. Oh, that's actually not the right data set. These live demos, you never know what's going to happen with the live demos. It's this one. I got it confused. Why don't I delete the wrong one so I don't make that mistake again? Every accident is given some accident ID. Right? Every accident has a location. There's a latitude and longitude location given for the accidents. The police force unit that may have been notified, may or may not have been notified, is also recorded, at least the police force unit that's responsible for covering the area. There's an accident severity, so some accidents are more severe than others. That's the number of vehicles involved, the number of casualties, the date of the accident, the time of the day of the week, like Monday through Sunday, the time of the accident, the local authority district, the local authority highway, the road class. So the roads are actually classified in different categories of how, like the quality of the road, how well it's lit, how well it's maintained, how big it is. And the road number is identified, the road type, the speed limit, the junction. So there's a lot of data here, right? We won't have time to look at all of it. Look, pedestrian crossing, human control, pedestrian crossing, light conditions, weather conditions, road surface conditions, special conditions at the site, carriageway hazards. This is a really, really big data set. It's very complicated. And if anybody's interested, this example, I just took some notes. Anybody want to guess how many accidents, recorded car accidents, there were in 2015 in the UK? That's a good guess. So it's 140,000, right, accidents in 20. So you're highlighting the limit of Excel. Yes, so Excel, Excel at the time could only read 65,000 rows, right? But not all data sets are carefully conveniently limited to 65,000 rows. Right, that this doesn't fit on the normal Excel spreadsheet. I'm using Excel just to give you a preview, but the first time I tried to look at this with Excel, it truncated the data down to 65,000, so I lost 2/3 of the data immediately, right? But that's a good observation. That is approximately 384 accidents per day, which is approximately 16 per hour, which is approximately 1 accident every 3 to 4 minutes. So there are lots of accidents, lots of car accidents, right? Good times. So the question is, how do we now look at this data? And this is what the demo is about. Now, if you want to know more about the data, there are descriptions about the fields, right, and things like that. Road Accident Safety Data Guide. This describes the columns in more detail. In fact, I'll leave this open just in case we want to look at it in more detail, but these are the variables. Right, and these are descriptors of the variables, like police force, accident severity. So we know the one is where the fatalities are. The days of the week are given numbers, right? So the first day of the week in this data set is Sunday. There are the local authority districts, the local authority highways, and so on, right? So all of the data is described here. This is more like the real world in terms of data, and well, it's real data, right? It's not just some made up thing. And the question is, how do you look at it? So let's see if we can look at it. So I'm going to start Tableau, hopefully, if I can find it. This is a very popular tool these days, Tableau. And when you start, probably you have a blank screen because you've never used it before. I happen to have some previous examples sitting there so that I could continue to work on. But I'll start a new example for purposes of this class. In the Tableau terminology, we connect to a data source. In this case, our data source is a text file. Does anybody know what a CSV file is? Indigo? Comma separated values. At some point I'm going to leave back and forth. Comma separated values. So it's a text file. A CSV file is a text file. All the values are there. In text, plain readable text, and they're separated by commas. So that's very, very popular format. Very popular, right? Because it's human readable and it's not limited to 65,000 rows or something like that. So we're going to click on Connect to a Text File, and we're going to try to find our cars, accidents, data set. So see if you can find your data set. I put mine in a one called car. And then open. Okay. An error when?
When I try to open the accidents file, it says an error occurred when communication with Excel Reader.
With the communication of what?
With communication with Excel Reader.
Okay, you don't want to use Excel or open an Excel file.
Oh, okay.
You want to open the CSV file. So you hit text file.
Oh.
Yeah, not Excel. And then, yes, CSV.
I save it on the desktop, but I cannot find it.
CSV, that's it.
So, okay,
Maybe not on the.
then cancel, how about cancel? If you hit text file, is that what you hit?
Yeah.
Text file? Oh, maybe, it's okay, desktop.
Have to save it to this desktop folder.
Where is it? Okay.
There we go.
Accidents, see it, did you open it in Excel already, I guess?
Yeah, but just this.
Okay, maybe close Excel, don't save. So this is the first one. Okay, let's just try it again, maybe. Okay, desktop. There it is. Refers to a location that is unavailable. It could be on a hard drive, on the screen, or on a network.
Okay, let's try to save it.
Is yours on your desktop?
No, it's saved to desktop.
Okay, maybe put it in the documents. Put it in the documents folder then. See if it works.
Oh, documents.
Anybody else stuck or everybody else with me so far? So save the accidents CSV file in the documents folder because it seems to cause problems if you save it on the desktop. And don't try to open it, don't think of it as an Excel file. We're in Tableau, we're connecting to a text file, not an Excel file. A CSV file is a text file. So those are two stumbling blocks. No luck? Maybe
I can change the computer.
maybe something went wrong because it turned into like an Excel file or something.
No, the problem we cannot find
The documents folder.
from the bases we have from. Okay.
Maybe you could just follow along.
Yeah, okay.
Someone else.
Yeah.
Someone that's surprising. Okay, so if I download the accidents CSV file, I stored it on my local hard drive, and then I opened Tableau, and I hit on connect to a text file. Did anybody succeed in getting this far? One person? Okay. Anybody else succeed? Okay, good, that's great. Then we see a preview here, a preview of the data and how it's being interpreted by Tableau. So there is the accident index. It's being treated as a string, right? That's what that ABC means. And this one is being interpreted as a number. That's the location. Right? This one is also being interpreted as a number. That's what this means. Here we have kind of special data, which is the latitude and longitude of the accident. That's being treated as location data, latitude and longitudinal data, which is very good news because we can now put it on a map. And so on. Right, there's the police force and so on.
I did it.
And we can keep going. I'm actually going to make one change. Day of the week is being treated as a number, but really it's a string. Well, I'm going to treat it as a string. Right, because it's just Monday through Friday. It doesn't matter that much. Actually, you can still do the same things, but it's really, in my mind, it's a string rather than, I don't refer to the days of the week as numbers. I like to think of them as words. Everybody lost all with me? So, lost, did I lose everybody? Okay, and then that's it for the preview. And then I can go to a worksheet. So I can double click on a worksheet. Yeah, you might get a message that says something like, are you sure you want to look at all the data? Did anybody get that message? No? Okay, good. Good.
How do you go to the worksheet?
You just click at the bottom on sheet 1, for example, next to the.
Not able.
Did you find it?
Yes.
Good, good. So this is where we start creating visual designs. At least that's one of the possibilities. And then I can, for example, if I want to see the map, the data on a map, I can double click on latitude. Does everybody see? So the data attributes have been divided into 2 categories. One's called dimensions and one's called measures. Right? The measures, the numerical data is down here. Right? These are all numbers and latitude and longitude values. And then some of the other ones like row number, the string-oriented data is up here. So we have latitude. We can double click on latitude, for example. Well, I can try. And then it just creates this, if I double click on it, it just creates a bar of average latitude. Not very exciting so far. If I double click on longitude, then suddenly it takes an average latitude and an average longitude, and it plots it on the map. Anybody get that far? Yeah, good, good. So which is nice, isn't it? Like that's the average latitude and longitude of all the car accidents in the UK. It's right in the middle, which is good. Now, what if I want to see the locations of the accidents? The accidents are given a unique identifier called an accident index. Right? That's logical. Question? Oh, okay. And I can drag the accident index to detail. Okay, that's where that message comes up. I forgot where the message comes up. Did everybody see that? I dragged accident index to detail, and then it says the field being added may contain as many as 140,000 values, and we recommend a maximum of 10,000. What do you want to do? Add all the numbers. We want to see all of the accidents. I can see 2 screens where it's working. Yes.
Our screens are not working, so what's going on?
Which part are you stuck on? Were you
Try
able
to see the, what do you call it now? Try to see the Excel file.
Okay.
Just go to file, see.
No. We don't need to use. We don't actually need to use Excel.
Yeah.
You don't need to use Excel for this. So you have in a file called accidents CSV, accidents 2015. This one. This is save link.
This one.
To you can do downloads of documents.
So this is basically software installed.
Yes. Yes. So
Then we go back to Tableau. Text file. How to download.
So that's instead of using Excel.
Yeah.
This. Yep.
I use this.
I change the day and the week from the number on the string. Yeah, and then I'm going to sheet 1.
Yeah,
Yeah.
Is it data type?
There's a sheet one. I double click on that.
It must just be extracted from the values within
Yeah, forget about the super. Okay, so we can move there.
Everybody with me? So this is already very exciting, isn't it? Like I'm already excited. I love to see data on a map. I love it. I want to see it on a map. Where is it? Actually, everybody loves data on a map. Everybody. It's a universal human desire. And you can, before we go further, you can move the map around. You can zoom in. And of course, we all want to look at Wales, right? Because we love Wales. We love South Wales. So we can type in SA2 8PP, and theoretically it will search for us. SA2 8PP, at least I thought it would. It sometimes works.
Not this time.
Okay. Maybe I will discover, maybe I'll remember how to do that at some point.
How come you're taking the average of the longitude and latitude rather than just the latitude? Presumably you want to use the actual. It's probably, I guess it's per data point, so it's just the average of one value.
Yeah, now it's showing the actual values. It's it's showing the average in the middle, but then it added all the individual.
You've got this average function around.
Yeah, that's right. But as soon as I dragged the accident index to the detail, it added all the individual accidents onto the map. So there's an average dot in there, and there are all the individual ones in there as well. Yep.
Is it just recognising that their latitudes and longitudes from the head of the column, from the name, or is it?
No, it does some. It looks for latitude and longitude. It
So
does
there's
some.
certain range in it in terms of
Exactly. You can analyze the data and derive some attributes. You just run a bunch of tests. Right?
So if your data was by chance in single ranges, latitudes and longitudes, could it interpret them wrongly?
Yes. Yes.
So lots of
Yep.
changes then.
Any other questions? So we can at least go down here and zoom into South Wales, right? And see some Swansea details if we want. Actually, it's over here, isn't it? There, I think that's Swansea.
To be able to track
Okay, now all the accidents look the same, but they're not all the same, right? Some are more fun than others. So we can drag accident severity. Let's look at accident severity. Right, and we can take that and drag it to color. And color these. Yep. And there is a button that takes us back to the original overview, but I don't remember which button it is. And then we can see, okay, they've been color mapped to accident severity. Now, the 1 is the fatalities, and the 3 is the not so severe. It's hard to see right now, the different accident severities. So maybe we can improve it to make it a little bit better. So we're going to update the color legend. Right, we can click on this color legend, and we can modify it. So we know that we have 3 categories of accidents, right? So we can change from a discrete scale to, well, from a continuous scale to a discrete scale. And we can also change the colors involved. I see. So we can do something like, well, we could do red, white, and green, for example, or something like that would be interesting, maybe. Or, I don't know, red, black, diverging. We could try some different ones and see which ones are the most interesting. Black, diverging. Maybe we'll try that one and see what it looks like. So then we can start to at least distinguish the red and the green. Right now, if we want, there's a lot of overlap, right? We would have to zoom in. The dots, the glyphs stay the same size, no matter what zoom level we're at. So if we want to see the detail right now and reduce the clutter, we have to zoom in. But we can take the number of casualties. So now the red ones are the severe ones. We can take the number of casualties and drag it to size. And then the size of the glyphs are changing depending on how many people were involved in the accident. Right? And then we suddenly it's very interesting and informative, and then we can start to explore those big fatal accidents with lots of people involved. Like here's one, and everybody notice how I can hover the mouse over the map and then get the original data values, the original data records. So here's a big accident, right? It's the severity, so people died and there were 9 people, there were 9 casualties involved. So that was a pretty big one, a severe accident. Right? And let's look at Swansea. We can zoom into Swansea, our favorite city. And there are no huge accidents. Okay, there's an accident in the Gower. That's a big one. There's at least 1 fatality and 5 casualties in the Gower in 2015. Probably along that strange road, that single lane road, and 2 cars just going boom in a single, or a bus in a car or something like that.
How is accident severity classified?
I don't know the details, actually. I just know that 1 means fatality, and then 2 is like middle, and then 3 is not so severe.
Because I found one with number of casualties 35, accident severity 2. So that's what I do.
With casualties, not fatality.
I guess so, okay. So
Yes,
fine.
yes.
Probably a bus.
Yeah, or something.
But you could look at the metadata sheet if you want to know more details. We look at the metadata sheet. This one here, actually, I still have it open. So accident severity, right there, it's just fatal, serious, and slight. So the 1s and the 2s are the most interesting. We can adjust the size of the glyphs, right? And it will adjust to different sizes, right? This is probably more useful if we zoom out. try to find the optimal size
Oh, wow.
of the glyphs.
No,
So, yeah, and then it's fun. I mean, that is, you can see how effective it is already, right? We can see the big fatal accidents all across the UK in just a second or two. They stick right out at us now, right? If I just gave you the spreadsheet and I said, please find them, it wouldn't be that obvious, and you'd miss some. You'd have it wouldn't be fun. Let's just say that. Any other things that map search into this? Okay, let me just try one. I thought that worked. Okay, maybe it works. Okay, so there's SA1. So I can do SA2. I should be able to do SA2. So there's SA2. Anybody know what that is? The airport, yeah. And there's Oystermouth Road, our favorite, heavily trafficked. You can see the roads. I mean, there's Oystermouth Road as it goes over the bridge, right? This is a horrible area to drive, right? Everybody knows that. It's all congested and the bottleneck. So you can see, oh, that's where a lot of the accidents are, so pay attention when you're driving along Oystermouth Road and over the bridge. And you can see it looks like sort of the Kingsway and so on. I can zoom in if I wanted and get a better view.
Is there a way to change the settings for the actual map itself rather than the data?
Yeah, I'm sure that this software is very complicated and very feature rich. So there are millions of features,
Yeah,
and you can change the data. You can change the map data. You can do a lot of advanced things with this software. Okay. We can then also click on, for example, day of the week. And we might want to know, like, okay, what's the best day to drive? Maybe, like, which day of the week is the most accidents or the least accidents? And we can say, for example, show filter. And then we can start to explore accidents based on days of the week. I'm just zooming out here, zooming back out. We'll look at this more. But if I want to see just the accidents on Mondays, I'm pretty sure it's Monday. Is it Monday or Sunday? That's why I don't want to use the Sunday. So these are all the accidents on Sundays. And if I want to see only the accidents on Mondays, right, that's a filter we can use. So we can add interactive filters that let us select subsets of the data depending on different characteristics. And we can rename that sheet if I double click on the name at the bottom to, for example, map, and save it, so to speak. I can then click on a new worksheet, for example. If I can, we don't have to, this thing doesn't just disappear, it stays. So maybe I want to create a different visual design that's not a map. I can click on a new sheet. Did everybody see me do that at the bottom?
Oh, yeah.
It's a good demo, isn't it? The intensity is so high.
It's too much, yeah.
Yeah, it's too much. So for in this example, this is going to be a very exciting bar chart example. So we can take day of the week and drag it to the columns. And then we can take, for example, the number of casualties. If we want to find out, for example, I don't know, which day of the week has the most casualties? That's kind of an interesting question, right? What's the most dangerous day to drive? And that's the Sunday. So Sunday is sort of the safest day in some respects. And then our favorite day of the week, Friday, is the most dangerous day. It's where people are dying the most. Well, I can only say that they're the most casualties from this. I can't say that they're dying the most that day. And you can see it's an interactive bar chart, right? I'm hovering the mouse over and I'm getting the different data values, right? And the bar chart is interactive. I can name this one, for example, bar chart. I could also name it like day versus casualties. Day versus casualties. And then we can create another sheet. For example, click on new sheet. We might be interested in something like, okay, I know Friday is the most dangerous day to drive. What about the time? Is there like a special time that might be more dangerous to drive at? We could take some guesses, like Bye.